Math Major 3217 Modern Geometry. What is geometry? The word geometry comes from the two Greek words geo means earth and metrin, which means to measure. So, originally, geometry was the science of measuring land. So let us go back to who started geometry. The Greek historian Herodotus, who lived in the 5th century BC, said that the Egyptians were the first people to develop geometry. But other ancient civilizations, like the Babylonians, Hindus, and Chinese, also had a lot of knowledge about geometry. How did early people do geometry? Back then, geometry wasn't exactly a science the way we think of science today. People didn't use exact rules or proofs. Instead, they learned by experimenting, looking for patterns, and making good guesses. Sometimes they were right, and sometimes they were wrong. Examples of early geometry. The Babylonians around 2000 to 1600 BC thought that the circumference of a circle was 3 times the diameter. They also thought that pi was equal to 3. The Egyptians, around 1800 BC, had a better guess for pi. They thought that it was about 3.16. They also figured the formula for a special kind of pyramid. Both Babylonians and Egyptians developed some rules for figuring out areas and volumes, but these rules weren't always accurate or based on logic. The Greeks did differently though, because the Greeks were the first people to develop geometry in a formal science. They came up with proofs to show why things were true in geometry, not just guesswork or rules based on observation. The Greeks changed the rules. Before the Greeks, people learned about geometry by experimenting and making guesses. The Greeks were the first to develop a logical system for geometry based on proofs. We also have Thales. Thales of Miletus was an important early Greek mathematician. He is sometimes called the father of geometry. He is famous for proving the theorem that says that the base angles of an isosceles are equal. Thales traveled to Egypt and learned some of their geometry. He may have even learned Pythagorean theorem from the Egyptians. The Pythagorean theorem is a famous theorem in geometry that says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Pythagoras was another important Greek mathematician who came after Thales. Pythagoras and his followers, which are called the Pythagoreans, made some important discoveries about geometry, music, numbers, and they discovered perfect numbers, odd and even numbers. The Pythagoreans also made an important discovery about the square roots. They discovered that the square root of 2, written as square root of 2, is an irrational number. An irrational number is a number that cannot be expressed as a fraction. This discovery surprised the Pythagoreans because they believed that all numbers could be expressed as fractions. So later, than Greek mathematicians, Hippocrates of Chios, not the famous doctor, was another Greek mathematician who came after Pythagoras. Hippocrates is credited with writing the first textbooks of geometry. However, this textbook has been lost. And now we also have Euclid. Euclid was a famous Greek mathematician who lived around 300 BC. He wrote the book called Elements, which is considered to be one of the most important books on mathematics ever written. The Elements included all of the important mathematical discoveries of Greeks up to that time. The importance of Plato and his ideas. The famous philosopher Plato, who lived in the 4th century BC, believe that there is a world of perfect ideas, and that the physical world that we see around us is just a shadow of these ideas. Plato thought that studying math, especially geometry, was a good way to train your mind to think about the world of ideas. He believed that geometry could help people to understand logic and reason. Euclid was a student of Plato who lived around 300 BC. He is famous for writing the book called Elements, which is considered to be one of the most important books on mathematics ever written. So, what was in Euclid's Elements? In Euclid's Book of Elements, he collected all the important mathematical discoveries of the Greeks up to the time, including facts about lines, angles, shapes, and solids. Also, it contains how to prove things in geometry. Euclid's Elements is based on a set of rules or axioms. These axioms are the basic statements that are assumed to be true. From these axioms, Euclid goes on to prove other mathematical statements or theorems. This logical approach to math is still the foundation of mathematics today. Math Major 3218 Abstract Algebra. What is abstract algebra? Abstract algebra is a branch of mathematics that studies the properties and patterns with algebraic structures, such as groups, rings, fields, etc., rather than focusing on traditional numerical calculations. Algebraic structures are sets with defined operations that follow specific rules and patterns. These structures are abstract because the elements within them are strictly numbers. Examples are groups, rings, fields, vector spaces, and modules. What is mathematical abstraction? It is the process of identifying common properties or patterns across different mathematical systems, then creating generalized frameworks to study them. Let us go back to the historical context. Early in the 19th century, the need to solve higher degree polynomial equations drove exploration of new areas of algebra. Évariste Galois pioneered the concepts of groups to address these equations. Carl Friedrich Gauss developed modular arithmetic, which shares properties with groups. New non-Euclidean geometries emerged, and groups help in analyzing them. Evolution of abstract algebra. The power of groups as a unifying tool led to the development of more abstract structures. Careful refinement of definitions ensured these structures were both broadly applicable and insightful. What are the significance of abstract algebra? Foundation for modern math. Abstract algebra provides the underlying principles and structures in many areas of advanced mathematics. It also has a wide-ranging applications. Initially theoretical, abstract algebra now has applications across physics, chemistry, and computer science. Evolving field because the usefulness of abstract algebra continues to grow with new applications being discovered regularly. Abstract algebra is also called modern algebra or simply algebra in advanced mathematics context. So, before we study abstract algebra, there are prerequisites. So, one needs to have a solid foundation in traditional algebra, experience with mathematical proofs, and capacity for abstract thinking. With this, you may be able to understand and grasp the concept of abstract algebra.